Hello and welcome to another case walkthrough. Today I'm looking at a case from the 2023 Excel World Championship called Flower Power. As this is an older case, it's one where there's only 5 levels and 3 bonuses compared to the cases at the moment which have 7 levels and 5 bonuses. This is a really interesting one. The approach I'm going to do in this walkthrough is not really that similar to what I did the first time I tried it under timed conditions, but as I like to do with these videos and the trading is I like to go through the case a number of times, work out what works, and in this case I kind of realised that it's an opportunity to practice building a let and turning that into a lambda that can then be replicated and kind of adapted for later levels where we have a similar task to achieve, but the parameters change. So I'm assuming if you're watching this, you've attempted the case or you're thinking of attempting it. The basic idea is that you get given these ranges that represent a garden, and every garden either has sunflowers, tulips, or in some cases a kind of dead bit of ground represented by an X where nothing can grow. And all that really happens is in each case you get given a cell location, and around the cell location basically anything within a certain distance upwards or downwards gets pivoted, and simply that means if it was a sunflower it turns to a tulip, and if it's a tulip it turns to a sunflower. So in some sense it's quite a simple principle at work, but the nature of the case is it starts as all of these cases are, they're kind of developmental and they grow giving your understanding. So by the second level you're actually applying pivots to a range, but then you start off with a small 3x3 garden, and then in later levels, as is quite customary, then the garden gets bigger, so the range gets bigger, and so you go to a 5x5, and then the last case you're doing with 10x10. So building a solution that only can deal with the 3x3 and then trying to upscale it or make it scalable for 5 or 10 or any size is something that if you don't do at the start can make it difficult to kind of adapt to those later levels. So the approach I'm going to take here will mean I'm basically going to spend about 7 or 8 minutes at the start just building my let, and I'll talk you through that because I find it helpful for my own understanding. And then once I've actually built that and turned it into a lambda, then actually doing the case doesn't take very long at all. This is not to say this is how this would go in a live case. You never really know that it's worth spending that time, or maybe you do. Some players do, who knows. Anyway, that's more than enough talking now. We're over 2 minutes into the video, so let's get going. I'm going to turn to the score sheet and I'm going to start my timer. 30 minutes. We're not going to need that, but just gives us something to aim for. So the first level doesn't actually need the work started, so all we're asked to do is say in this range how many sunflowers are there, in other words how many S's are there. So we can use countifs here, so select this range and we're looking for sunflowers, so that's capital S, and then we can just fill that down. So that's just a nice easy one to start us off. So we can post our answers in here and we get 60 points. Then on level 2 straight away we're going into the idea of we've got a garden, they give us the coordinates, the contents, and then tell us which cell is going to be pivoted, and it's our job to work out at the end of this how many sunflowers are left, but we have to do the whole transformation. So I'm going to build a data table and I'm going to actually take the time to build my let, which will turn into a lambda as well. So we've got basically 3 bits of input. So we need to know the cell that's being pivoted, which in this case is in cell B1. We actually need to know the distance because, although that's not obvious when we first start the case, in the last level the distance that we have to reach out changes, so we want to build that in from the beginning. And then we need to know what the garden kind of map is, and in this case that refers to these 9 cells here. So what I'm going to do is I'm going to start building a let. I'm going to have all of these as an input, so we'll just give them really obvious names. So our cell refers to this, we'll call distance referring to that, and we'll call garden referring to those cells there. And so if I just choose one of those, for example the garden, just to demonstrate what the output is, you'll see this being built at each stage. The first thing I want to do is put this into the actual shape of the garden because currently it's in a row, but to do that I need to know the size of it, so because this could be more than 9 cells in future. So I'm going to create a variable called size, and what I'm going to do is I'm going to take the square root of the number of columns in our garden. Okay, and the reason I'm doing that is because if we have 9, the square root of 9 is 3, which means it's a 3x3 grid. If we had 16, it would mean it's 4x4. Since we're always dealing with squares, that's going to work for now. theoretically we could have had gardens that were different shapes, but in this case it's only squares, so that's how I'm going to do it. So our size is that, and then we need to kind of be able to use from that we can actually create, I'm going to call this my garden map, where what I need to do is wrap in columns my garden with the number of columns based on the size. And when I put that as my output, we now see we've got it, and because it goes down through, so TXS is the way the case gives it to us. It could have gone the other way, but that's where they could have gone A1, B1, C1, but actually they did it A1, A2, A3, so that's why we have to use wrap cols rather than wrap rows. So that's our map. So what do we need to do next? We need to know what the actual references for each of these are. So we're going to build basically some addresses. So I want to build the addresses. So what I'm going to do here is I'm going to basically use the address function, and my rows are going to be a sequence of rows that's a sequence the same size as our size. My columns are going to be the same again, except I'm going to have a comma and then put size. So we have a sequence going to crossways, and then we want to put that in relative references. So if I now put addresses, we've got our addresses. Okay. What do we need to do next? We now need to work out the distance from each cell in the map to the kind of pivot cell. So I'm going to import lambdas here because I'm going to use the distance lambda. And let's call this distances. I know these are quite long aliases I'm using here, but this is for teaching or learning purposes. So this distance is, we're going to take the distance from the cell to our addresses, and our height, we can go 1, 1, 2 because we can go up and down, but if we want to go diagonal, we actually have to go up and then down, so it's effectively the same as going 2. So if I now put distances, we now see that from C1, which is the top right, is 0, and it goes along 1, 2, 3, 4, and so forth. So those are the distances. So the next thing we need to do is work out which stuff is within range of our cell. So I'm going to call this in range, and what I'm going to do is I'm going to say distances less than or equal to our distance variable. And when we put that in, we're going to see a series of trues and falses, and the trues start up here in the top right because that's where our closest was. Maybe it'd help if I just put that in yellow so you can imagine that. And if I change the distance, you'll see that more of the cells become true, and if I go back down, we only have the ones right next to it as possible ones that are going to be pivoted. Okay, so that's all working exactly as I would expect. So the next thing we need to do is we need to do our pivots. So what we're going to do is we're going to say our pivots, we're going to say if we are in range, so if we have a true in our map, then what we need to do is we need to perform a switch. So we're going to switch in our garden map, and what are we going to switch? That's our value we're looking at. And so if we have a T, then it becomes an S, and if we have an S, then it becomes a T, and if we have an X, it stays as an X. And those are our switches. If it wasn't in range, if it was false, then we're just going to leave it as the original garden map. Okay, and so if I now go to pivots, we now have a bunch of results which it's difficult to see that it has changed, but basically those top 3 have changed. Okay, so they've gone from S to T. So the quick way to show you that is if I change this back to garden map, these we were S, 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 everything else stays the same, so TXS and so on. But when I change that to pivots, we see it goes T, T, T. So that is what happens if it changes. However, if our original cell is an X, we don't do anything. So that we've got to build that into our calculations. So let's just call this can pivot. Okay, so we're going to have a register, so can pivot. So we want to basically find what the value of C1 is, or what the flower in C1 is. So what I'm going to do is I'm going to say if addresses equals cell, then return what is in the garden map. Otherwise, I'm just going to put an N for no reason, except for what you'll see in a moment. And if I put can pivot, what we get is basically for every cell that's not C1, we get an error, and for the one that is C1, we get what was in that original cell. And now, so if I now put to col around that and put a 3 at the end where it filters out errors and blanks, we actually just get RS. And we actually want to know we can pivot as long as that doesn't equal x. So as long as that doesn't equal x, so we get a true. So in this case, we can pivot because when we look at what's in that place, if I go back to our garden map, it's an S. Okay, so we're now ready to do the final step of our let, where we're going to say, basically, if can pivot is true, then we want our pivots. Otherwise, we want the original garden map, because if it was an X, we're not allowed to do anything. And that's our output. We'll call that our results, but there is one last step to make life easier, is I don't want my output to be in this 3x3 grid. I want it to put it back in a row. So later when I do this multiple times, it still just takes up one row. So I'm going to put this in a 2 row. And because I want to get it back to exactly the same shape as before, I scan by column. And so we end up with our output. And what I'm going to do is I'm going to use OA, actually, no, for the purpose of learning, I'm going to turn this into a lambda. So I had 3 things that I needed to input. I needed to put in the cell, the distance, and the garden. And because I've now put those in my lambda, I can take them out of the let. And just for the purposes of example, if I don't do anything, it just returns an error because I haven't got any inputs. But if I now put that as my cell input, that as my distance, and this as my garden, I now get the output. And so I'm going to, again, do this the old-fashioned way. I could use OA robot as well. I'm going to copy that, go to formulas. We'll define a new lambda called garden pivot, and our formula is what we just pasted there. Okay, now let's go on to level 2. So, well, we're already on level 2, but let's actually do it. So what we want to know is garden pivot of this cell and this range. Oh, no, need to put my distance of 1 because we've just been told it's 1 for the moment. And that's what we get. And we want to know how many, in this case, how many no, that's level 1, how many sunflowers after the pivot. So we're going to sum where this range equals sunflowers. And we get 2 and paste that in. So I'm going to copy those over. So on our timing, we've used up nearly 10 minutes. You're thinking, gosh, that's a lot just to get to level 2. We get 160 points, but now everything else is going to be much quicker. So we're going to level 3, where we basically now have to consider every possible option of where to put our pivot and work out which is best. So I'm going to paste all the options here. I'm going to put this underneath the options. And what I want to do is, if this doesn't equal x, because if it doesn't equal x, then we can actually, we're going to say garden pivot on this cell with a distance of 1 on this being our garden, and we'll lock that in place. Otherwise 0. But that actually does the whole pivot, and we actually want to just know a number, which is how many tulips there are. So we will then say sum of that equals t, and we get a number. And now if I fill that to the right, we get all our different numbers, and then you just want to know which is the best option. So we'll take the maximum of those, copy that, and so the last question took us 8 minutes. This question's taken us 1 minute because we've done all that good work. Okay, let's go on to level 4, where we've now got a 5x5 grid. So we'll set up our table, grab our 5x5, paste this in here. So we need to firstly get this into a row. So we'll 2 row this scanning by column. So we've now got our first input, and then our pivots that we're going to do are these. So we'll put those in a column, and we'll just say garden pivot on this cell, distance of 1 based on this input. And now I'm going to drag that down because each time we're just going to take the one above. And for this question, is it sunflowers we want or tulips? No, it's tulips. So we want to again know the sum of where this equals tulips, and we get 9. And we'll put that in there, and we get our answers. And we'll go to our score sheet, and 220 points. And again, that one's just taken us over a minute. And then case level 5, final level of this case, and then we'll go on to the bonuses. So this time we've got a 10x10 grid, and they tell us the distance is now 2, so we can go 2 in each direction. So we will paste our original grid in. We'll do the same thing as before, turn this into a 2 row, scan by column. Oh, what have I done too? said the word scan. I should have said true. Okay, and what we need to do is we need to get our cell pivots, which are the original input. So we're going to say garden pivot this cell, distance of 2, and garden is that. And we will drag this down so we get all of them. And on this question they want sunflowers, so we'll say sum of how many of these equals sun, and we get 49 for the example, which is what we should expect. And we'll take our answers and we will go through here, and 360. So again, that's just taken us another minute now that we've done all that hard work. So let's go on to the bonuses. So first bonus is, I think the first bonus is actually the most difficult, just because it's really, really awkward. It says across all the gardens in games 1 to 100, excluding examples in their initial state before pivots, how many sunflowers are there in total? So let's just add an extra sheet, and the first 3 levels are nice and easy. So I'm just going to call a V stack of this range here, and this range here, and this range here, which is nice and easy. Okay, but then for the other ones, they are there's only one range, but we have to multiply or stack it multiple times. So I've got a stacking lambda of this called stack collation. I'm going to take my array, so it's this array, and on level 4 there are 20 rounds, so that's 20 of those, and let's just put that into a single column just to tidy things up for now. And then we'll do something very similar for the last question. So we'll call and we'll stack collation based on this map here, 30 times this time, and those are our all 5 questions now covered. So if I now put all of those together into a single stack, and that should cover all 5 questions, and I'm going to use my most least lambda on that range, which is just a group by, and we see that S comes up on top 2043 times. So that, we'll copy that there and we'll just paste it into the score sheet. Took us 2 minutes compared to round level 5, so it took longer than the original or the final level, which I thought was interesting. Right, there are a total of 100 cells in the garden level 5. One cell is mentioned most frequently. How many times? So level 5. So let's just get a bit of space over here. Let's call this range. So it's a single column, and then let's use most least, which again is just a group by, so it's not saving us a massive amount of time, but it is enough. Oh no, it's not the garden. We want to look at the actual cell references. So I've looked at the wrong thing. So let's take that and let's just use the mouse here, which is a little bit slow. Not good habits, but there we go. And G9 appears most often, and it appears 16 times. So there's 16. Let's copy that over to the score sheet. We don't get the result feedback straight away, but I think we're okay. And then in level 5 garden, you are now making consecutive pivots going cell by cell. How many tulips will you have after all 96 be made? Because 4 cells contain X's, so they don't actually pivot, which our lambda takes into account. So we'll make a copy of level 4. And also level 5 even, and this time instead of using from the question, I'm going to call the cell column headers and the row headers, which will give me every single address. There's 100 of those, and then we just remove this and fill this down, which would be the equivalent of going through every single cell, some of which would mean no changes because they are actually an X, and we want to know the sum of where this range equals T for tulips, and I put a minus rather than a equal, and we get 43, which when we put into our answers should give us the correct answer. And there we go. So 1250 points, stop solving early, 60, just under 17 minutes rather. And let's just, for the sake of neatness, put our answer in here as well. So yeah, as you can see, I mean, like I said, I would never have thought when I first did this to build a Lambda right from the beginning, but actually I think it's taught me that sometimes it's worth just quickly looking ahead at the later questions to see on these developmental cases where what you build in the first levels might come in handy later, but needs to be adaptable, so needs to grow or be able to deal with multiple inputs and so on. Sometimes that's worth it. Obviously, OA Robot, for those of you aware of it, could potentially handle that. But if you kind of know what you're doing, building that, where did I build it? I built it here. That Lambda from the beginning can be really, really helpful. So yeah, I quite liked that as a case. Very tough first time through, but yeah, nice, interesting one. Learned a bit, and actually useful stuff for future cases. So thanks very much for watching.